Section 12.2, question 22, find the volume of the given in solid. Under the surface of z equals 1 plus x squared y squared, and above the region enclosed by x equals y squared and x equals 4. I've already got this problem worked out because I accidentally recorded this video to the cloud instead of recording it on my computer to put onto YouTube. So I'm just going to give you a recap of what happened. First thing I did is sketch the region. X equals y squared is a sideways parabola opening to the right with a vertex at the origin. X equals 4, of course, is a vertical line. And the intersection of those two are the points 4, 2 and the 4, negative 2, which you can find by solving y squared is equal to 4. Because the left side of this is the parabola and the right side is the line, we're going to do left to right first. So we're going to do dx first, and we'll do dy second. So here you see the integral, and I'll do some highlighting here since I've already got this filled out. Let's draw a box, and let's make it yellow. So we started by setting up the integral dx from left to right. On the left, x is equal to y squared. On the right, x is equal to 4, followed by the dy. So from bottom to top, on the bottom, the lowest coordinate, the lowest y coordinate is -2, the highest y coordinate is +2. And then, of course, we started with the inner integral. That's not what I meant to do. Try that again. There we go. All right. So we start with the inner integral here, which is very straightforward. The antiderivative of 1 plus x squared, y squared, with respect to x, is x times 1/3 x cubed y squared, being evaluated from x equals y squared to x equals 4. When we put in x equals 4, we got 4 plus 64/3 y squared. When we evaluated at x equals y squared, we got y squared plus 1/3 y to the 8th. Upon distributing and combining like terms, we ended up getting -1/3 y to the 8th plus 61/3 y squared plus 4. And this will be a good opportunity for me to fix something that I did not fix earlier. I just want to make this 8th power a little further away from the 1, so it doesn't look like there's an 18 in the problem. Let's see. Okay, so we need an 8 right here. There we go. All right, so now we're going to evaluate the integral of that thing from -2 to 2. And that evaluation, as I mentioned in the first time I tried to record this, is just a calculus 1 question. The antiderivative of the integrand was -1/27 y to the 9th plus 61/9 y to the 3rd plus 4y. And evaluating that from -2 to 2. Evaluated at 2, we got -512/27 plus 488/9 plus 8. Evaluated at -2, we got pretty much the exact same thing, but all the signs were opposite, which makes sense because the antiderivative was an odd function. And when we put it all together, we got 2,336/27.